Week 5, lesson 4. Okay, so you can read this example. There's a game, all right? And there's going to be somebody that's charging you to play their game, right? You roll the die and you get $3 for every dollar that is on the die, okay? So the question is, as the person running this game, as the banker, how much should you charge so that you're actually making some money? So in order to do this, you need to know what the expected value is. So the way to do this is we're going to use a linear equation. That would be this one, okay, which makes sense because you're paying out 3 times the amount that's on the die. So if we just fill in 1 for each of these x's, we'll get 3, 6, 9, 12, 15, and 18. All right, and then the probability of each of these numbers coming up on the die is really the same, right? It's in a perfect world, each of these will come out 1/6 times. So to find the expected value of y, right, and we're using y because of this linear equation, you take the number times its probability and add that to the number times its probability, etc. And if you break that all into your calculator, we should get 10.5, right? Or in other words, $10.50. That's the expected value that the banker will be paying out. So he probably should charge more than that so that he doesn't go broke. Okay, in this box, you're seeing the definition of variance. You've seen variance before. So this here, let me make sure I have a pen. This is the expected value. Okay, which you know how to calculate. And this is, again, really, really similar, but instead of multiplying by x, we will be multiplying by x squared. Okay, so on the next example, we're going to do this one by hand, and then the last example we'll do in the calculator, just so you have an idea of how this works, and you will be expected to be able to do it both ways. Okay, so on this one, it says that 2 discs are drawn without replacement from a box containing 4 blue and 3 red. Okay, X is going to be defined as the number of blue discs. Okay, the number of blue discs. So for this probability distribution table, first I'm going to make a tree diagram. Right, I just need to sort of organize what happens. Right, I reach into this box. I could get a blue, or I could get a red. And the probability here is 4/7, and the probability here is 3/7. And then I could reach in again, and I could get blue or red, and I could get blue or red. But the probabilities are different here because we didn't put that first disc back. All right, so if I multiply down the branches and I get all these probabilities, this one is 12 40-seconds. And this one is also 12 40-seconds. And this one is 12 40-seconds. And this one is 6 40-seconds. Okay, so let's set this up. What are the possible number of blue discs? Well, here you get blue, blue. Here you get blue, red. Here you get red, blue. And here you get red, red. So we could have no blue discs. We could potentially have 1 blue disc, or we could have 2 blue discs. All right, the one for 0 is 6 40-seconds. The one for 1 blue disc, right, is these 2, which when you add up is 24 40-seconds. And this is the only way to get 2 blue discs, which is 12 40-seconds. Okay, and those should add up to be 1. Right? Add those fractions, you get 42 over 42, which equals 1. Okay, let me scroll this up just a little bit. Okay, so we're going to try and find these 4 things. So the first one that we're finding here is the expected value, which, and I probably have to move this down just a little, right about there. Okay, so the expected value is 0 times 6 40-seconds plus 1 times 24 40-seconds plus 2 times 12 40-seconds. Okay, again, handy dandy calculator, be able to do this both as a fraction and as a decimal approximation. Okay, now for the expected value, the expected value of x squared, instead of these numbers being what they were, you have to square them. Okay, now again, in two of those cases, it doesn't change it, but in other examples, it will. All right, and again, make sure you are comfortable in your calculator getting this both as a fraction and as a decimal. You will be asked both. Okay, so now when I scroll this up, this is where you have the formula on the prior sheet. It is the expected value of x squared minus the expected value squared. So let me highlight some stuff. This you found here. Actually, I'm probably going to use the fraction. And then this you found here, but we have to square it. Okay, so let me fill those numbers in. So I'm going to have 12 sevenths minus 8 sevenths squared, which is 20/49. Again, handy dandy calculator, which is approximately 0.408. And then standard deviation is always just the square root of the variance, which in this case is, and those should be squiggly, approximately 0.639. Okay, now scrolling up, okay, we're going to do, again, very, very similar problem, but this one we will do in the calculator. Okay, so 2 dice are rolled. We're going to let S be the random variable, the sum of the dice. Let's construct a probability table. So you could get a 1, a 2, a 3, a 4, a 5, or a 6 on the first roll. And then you could get a 1, a 2, a 3, a 4, a 5, or a 6 on the second roll. All right, and so we're going to construct this with the sums. So that's a highlighter. Okay, so the possible outcomes across the top are you could get a 2, a 3, a 4, a 5, a 6, a 7, an 8, 9, 10, 11, or 12. Those are the possible sums of the dice. All right, now there are 36 possible outcomes there. One of those is a 2. 2 of them are a 3. All right, and again, you can count. And as you fill out the rest of the table, you can see that it maxes out here with the 7s being the most, right? That happens the most often. Okay, so now what you're going to do is you're going to put the numbers in the top row, these numbers in list 1, okay? List 1. And the bottom row, these, you're going to go ahead and put those in list 2. That's a highlighter. List 2. Okay, I'm going to switch to the other program and show you how to get the remaining answers here. Okay, so if you're looking at my screen, you can see that I've entered into list 1 and to list 2 what I told you to enter. List 2 does convert it into decimals. I realize like in the cell itself, it's rounded, but down below, like here, you can see the very long decimal. And it's stored as a fraction in its memory. So it will do very accurate calculations. It won't do them with rounded values. Okay, so for list 3, I'm going to multiply these two things together, right? So I'm going to move over here to the right. I'm going to go up 1. I'm going to multiply list 1 times list 2. So that I have those products in that column, and then you know how to find the sum. And if you actually find the sum, you should get a sum of 7. In fact, let's just double check that. Okay, so I'm going to get out of here, and let's find the sum of list 3. The sum, number 5, of list 3. And let's just double check that we do get 7. Okay, perfect. So that's the expected value. The expected value is 7. Okay, let's go back to sorry, I hit the wrong button. Let's go back to stat and let's edit and let's go over to list 4 and we'll have it calculate the expected value of x squared, okay? Which means that I want list 2 times list 1 squared. And again, that should fill in for you. And then we're going to get out of here and we will find the sum of that list. So the sum of list 4. All right, and we get 54.8 to 3 significant figures. Okay, and again, I'm hoping you're writing those on your paper. So now if I want to do the variance, I'm going to take the 54.8 that I just found, 54.8, and I'm going to subtract the expected value, which is 7 squared. And I should get 5.8. It's funny, on my paper I have 5.83, and I'm wondering what the difference is here. Not quite sure. Oh, I know what it is. I rounded. Right here, I rounded when I should have taken this number. Here, let me show you the difference. Let me take this number, right? Now that it's highlighted and I hit enter, it will use that number. So now when I subtract the 7 squared, I should get a more accurate answer, okay? Again, the lesson here, do not round, right? If you're doing long calculations, keep the long number inside your calculator. All right, and then as far as the standard deviation, right, the very last question on this note page, all I have to do is the square root of the previous answer. And again, I would keep the long answer in there and get 2.42 to 3 significant figures.